Hello boys and girls, welcome to lesson 6-3, Algebra, Variables and Expressions. This lesson is found on page 449. Okay, so what is algebra? Algebra is a language of symbols including variables. What they mean by variables is something that can change, okay? A number that can change. And symbols meaning letters. A variable is a symbol, usually a letter, used to represent a number, and it usually represents a number that we don't know or a number that can change. So let's scan the lesson and complete the graphic organizer. Well, we don't really have to scan the lesson, we can answer this together. What is the math meaning of variable? Here it is. So it's a symbol, usually a letter, used to represent a number, okay? A number that we might not know. The everyday meaning means able to change or vary. Like the word vary, see, variable comes from variable, vary. To change, okay? As in variable winds. The winds can be strong or mild, so on. What's an example of a variable? For variables, we can use letters such as x, a number. It's a number that we don't know. We can use y. We can simply use a or b and so on, okay? Those are variables. Non-variables would be, for example, 3. We already know that it's 3, or 6, or negative 10. We know what these numbers are. We're being told what they are, so they're not variable. They're already a constant. I want you to imagine that for each one of you, I have given you all a handful of pennies, but you don't know how many pennies you're getting, so we're going to let x represent the number of pennies. Some of you got 6 pennies, some of you got 12, some of you got 8, and so on. And then after that, I'm going to add to each one of your hands another 5 pennies, another 5 coins. We would write it like this. We would write it as the number of pennies that changes from person to person plus 5. We all know that everyone has at least 5, right? We know that because I gave everybody 5, so this would be our constant. This is a number that was the same for everyone. But this is the number that changed from person to person. Some people might have gotten no pennies, so they have at least 5. Some people might have gotten 10 pennies, plus the 5, they have 15. So depending on how many pennies you got, depending on what x is, which is the variable, everyone's answer is going to be different. Here's an example. A box contains an unknown number of markers. Unknown number, see? That's our variable. There are 2 markers outside the box. The total number of markers is represented by the diagram below. So unknown number of markers. Let that be x. And we know there's 2 markers on sides, and so it's plus 2. So we know for sure there's at least 2 markers. We don't know how many are in the box. So there's our variable plus 2 markers. Okay? But now let's assume that there are 14 markers in the box. Find the total number of markers. Explain your variable. So they're telling us now that x equals 14. X is 14. So what's our answer? Well, our answer is 16 markers. Right? 16 markers. If there are 14 markers in the box plus 2 outside the box, it looks like 14 plus 2 equals 16. So we would replace this variable here with 14, and we continue to add our 2, and we get our 16. And here's essentially what we just did. We wrote an algebraic expression. X plus 2 is an algebraic expression. And it contains at least one variable and at least one operation. Okay, a variable and an operation. What are we going to do? We're going to add, subtract, multiply, divide. For example, the expression n plus 2 represents the sum of an unknown number and 2, the sum, adding. Okay, as you can see there. Sometimes we might multiply instead, and we might say there the letter x is often used as a variable. To avoid confusion with the symbol x, there are other ways to show multiplication. You know, we typically use x. I was taught in earlier years that we write 5 times, and then we actually make the x curvy and larger. Okay, but in order to avoid confusion, they make it a dot, or they just put parentheses. You know, parentheses means multiplication when there's no symbol between the number and the variable, or simply just write 5x, and you know that that's being multiplied. And once you replace the variable, you can evaluate or find the value of the algebraic expression. So if I tell you what x is, let's say I tell you, well, x equals, I don't know, 2. then you can evaluate. You know that 5x is the same as 5 times 2, right? Because I just told you x equals 2, which equals 10. Now you're probably wondering, where did you get the 2 for x? I just made it up, boys and girls. I don't know what x actually is. I just gave it a value so that you can see how it works. We would actually have to solve for it if we have an equation, but we don't, so I just gave it a value for now, just in a guess or an assumption. And now they're telling us x minus y. Here's two other variables, and they're telling us the value of x is 64 and y is 27. So we do 64 minus 27 equals 37. And here they want us to evaluate 6x. Now it's 6 times x if x equals a half. Remember, when you multiply a number times a half, it's going to give you half of that number. So 6 times a half is going to give you 3. Whenever you multiply a number times a half, you get a half of that number. This should be familiar to you because I do remember doing this in 5th grade with everyday math. Now just replace the variables. You know that a is 6, so replace that, and b is 4, and c is 1/3. So remember, if you multiply a number times 1/3, you're going to get 1/3 of that number. So what's 1/3 of 9? Well, what's 1 part of 3 parts of 9? It's 3, right? Okay, let's replace all the variables. You can see that I've replaced all my variables in red. Okay, every letter was replaced with the value of that variable in red. So 6 plus 8 equals 14. 6 minus 4 equals 2. And 9 times 1/3 equals 3. If you don't remember how to do this, remember that it's 9 over 1 times 1 over 3. Right? And then you multiply straight across and you get 9 on the top and 3 on the bottom. And when you divide, 9 divided by 3 equals 3. And we're going to evaluate multi-step expressions. To evaluate multi-step expressions, replace each variable with the correct value and follow the order of operation, PEMDAS. Okay, I'll be looking to see that you wrote the word PEMDAS next to example 4. Okay, I'll give you the check mark to see this is a key answer. Please copy it down. Okay, evaluate 5t plus 4 if t equals 3. So we're going to replace t with 3, as you see there. 5 times 3 plus 4. Remember, PEMDAS says multiplication comes before addition. So 5 times 3 is 15, plus 4 equals 19. Okay, the same concept goes with number 5, except now we have an exponent. And we replace, remember, the exponent only applies to the x. Got it? Otherwise we would have parentheses around it, and with the exponent outside, something that looks like this for x, and then we have a parentheses with the 2 on the outside. The parentheses now apply, not the parentheses, the exponent applies to the entire expression, right? But when there's no parentheses, like so, like we have now, it only applies to the variable, to the x. So now we have 1/8 times 1/8 equals 1/64. Remember, because you multiply the denominators, 8 times 8, it's going to give you 64. And now 4 times 64 is going to be 1/16. 4 times 1 is 4. 4 over 64 is 1/16. Okay, let's replace the a with 1/5. So we have 1/5 there, replacing the a, remember. And what is 1/5 of 10? Well, 1/5 of 10 is 2. Right? 1/5 of 10. Remember that when we multiply, we're saying pretty much that we're looking for the off. So it's 1/5 of 10. That's multiplication. So we can just simply do 10. 1/5 of 10 is 2. Sorry. We write 2. And it equals 9. Okay, if you're feeling confident, please try these 3 on your own. Make sure that you show your steps, you show your work, okay? Pause the video now. Okay, for E, I have to replace D with 12. Okay, D with 12. So I'll go ahead and now I do PEMDAS, multiplication before subtraction. So 2 times 12 is 24, minus 5 equals 19. 50 minus 3 times 12, right? Because 3D is 12. 3 times 12 is 36. So I can go ahead and write my 50 there, minus 36 equals 14. And 9e squared, e is 1/3. Okay, so I've replaced my 1/3 there. Now it's going to look more like this. 9 times 1/3 times 1/3, right? 1/3 times 1/3 equals 9 times 1 over 9, right? And then 1/9 of 9. What is 1/9 of 9? Well, 1/9 of 9 is 1. Or if you were to actually multiply it out, you would put 9 over 1 times 1 over 9. Okay, and when you multiply it out, you get 9 over 9, which equals 1. Okay, please take a look at example 7. If you have any questions with example 7, please ask me in class. We will look at it in class as well. But for the sake of time, let's skip this. Well, I'm going to skip it on the video, but please, you pause the video and read it through and make sure that it's clear to you. If it's not, ask me in class. And here's the guided practice. Please save it for our warm-up in class. But please complete the entire independent practice. Okay? You should be able to do all of this quite easily if you were paying attention and you learned today's lesson. Don't forget that you also have the back 11, 12, 13, 14, and 15.